Now, we know that at the beginning of the problem, there's a car that's driving east. Okay, so it goes from west to east at 60 kilometers per hour, and then it changes its direction in 5 seconds, and it starts moving to the north at 60 kilometers per hour. 2. Okay, so we find that we have data in seconds and we have data in kilometers per hour. Most of the time, we're gonna work in meters over second, so it would be convenient to change everything to meters over second. So I'm gonna just change 60 kilometers per hour into meters over second. That is 1,000 meters are 1 kilometer, and 1 hour is 3,600 seconds. Yep. So if I just do the math, that would give me 16.66 meters over second. Okay? Now, here is exactly where the analysis begins. Yeah, why is that? Because at the very beginning, in the first movement, the initial velocity, uh, yep, the initial velocity is um, just I. It has just an I component, okay? Because it is 16.66 I plus 0j. This is because it's just moving over the x-axis, okay? On the other hand, the final velocity would be 0I because it has no x component right here, plus 16.66 j. Okay, now I need to find the average acceleration of the car. If you remember correctly, you should know that the average acceleration, is defined as, sorry, the vector thing is missing here, and here too. Okay, the average acceleration is defined as the final velocity minus the initial velocity over final time minus initial time. Okay, that is, final velocity would be just 0I plus 16.66 j minus 16.66 in I plus 0j, and all of this divided over 5. So actually the result of this would be minus 3.33 I plus 3.33 j, and this is in meters over second squared. Okay, this is not the answer because it's in a rectangular form. We're being asked above to get the magnitude and to get the direction. Okay, so forgetting the magnitude, we should still keep working. And this, how do we get it? You remember the average acceleration? This is still a vector, so we can just get its components and find the magnitude, just like in any other vector. So that would be like 3.33 squared plus 3.33 squared. This is the I component, and this is the j component, and that would give me 4.71 meters over second squared. Okay, so this is actually a part of my answer. Okay, the first part. For the final part, let me just change the color to another type of blue. The other answer, that with the angle, would be the arctangent. Theta is actually the arctangent of the y part over the x part. That is 3.33 over minus 3.33, and that is minus 45 degrees. Okay, and that would be the answers. Okay, this one over here and minus 45.